All right, so we shall look at how to calculate the relative molecular mass of different molecules. All right, so this is our chemistry class. So we shall look at calculations, calculating so the relative molecular mass. So let's take, for instance, we have, this is a molecule of ammonia. So we know to say in this molecule of ammonia, we have one atom of nitrogen and 3 atoms of hydrogen. So what does this mean? We are going to say nitrogen, whose mass number is 14, and hydrogen, whose mass number is 1. So in this case, we know to say in hydrogen, which is just 1, we're going to say 1 multiplied by the mass number there. Then hydrogen, where we know to say there are 3 hydrogens, multiplying by the mass number, which is just 1. So in this case, we're going to say 1 multiplied by 14, simply 14, and 1 by 3, which is just 3. Then we are going to add. So we're going to have 17 grams per mole. Remember, the unit here is gram per mole, and here it's gram per mole. So we have that as our final answer. All right, so what if we have a molecule of sodium sulfur trioxide? So here we are going to say we have 3 atoms of oxygen, but we know to say the mass number for oxygen is 16. So we're going to say multiplying by 16. Then we have sulfur there. How many sulfur do we have? 1 multiplied by, what is the mass number for sulfur? So we know to say sulfur is 32. So we are going to say this multiplied by that, this is 48. Then this and that, this is 32. So when we add 48 to that, we see there's 8 and 2 here to give us a 0. Then 4 plus 3 there to give us a 7, plus the one that we had here, we are going to get 8. So that is our final answer. Now, what if we say, okay, we have nitrogen dioxide. Okay, here we are going to say we have how many atoms of oxygen? We have 2 of them, multiplying by, what is the mass number for oxygen? This is 16. So we are going to say the next one is nitrogen. Nitrogen, how many nitrogens do we have there? So we only have 1 nitrogen. What is the mass number for nitrogen? It has got a mass number of 14. So when we multiply 2 and 16 there, we get our answer as 32. When we multiply 1 and 14, we get 14 as our answer. Then from there you add you add 2 to 4, which gives you a 6. 3 and 1, you get a 4. So that is your answer. Now quickly try out try to calculate for sulfate. Okay, like that. Try to calculate the RMM for that molecule. Try to calculate the RMM for that molecule. Sorry for that disturbance. Okay, so let's see what you have gotten. So okay, so for sulfur, for that sulfur tetraoxide, we have sulfur and oxygen there. So we shall say we have 4 oxygen atoms multiplied by the mass, which is 16. So oxygen has a mass of 16 grams per mole. So you are going to multiply that. Then you say, how many sulfur do you have? You have 1 multiplied by the mass of sulfur, which is simply 32. So you are going to add that. So according to my calculations, 4 by 16, this is simply 64. Okay, so that is 64, and 1 by 32, we know to say it is 32. So we can add this to that to give us a 6. Then we can add this and that, it will give us a 9. So we have a total of 96. All right. So the next subheading that we shall look at in this chemistry concept, it should be calculating the relative formula mass. Relative formula mass. Okay. So let's quickly run through how to calculate the relative formula mass. Relative formula mass. Okay, so now what is the difference? Because you realize that for the relative formula mass and the relative molecular mass, you have almost the same procedures. So you have the relative formula mass here. Now here we can give an example of sodium hydroxide. So somebody tells you to say find the relative formula mass for this. Okay, so you should be able to note that during calculations for the relative molecular mass, which is abbreviated as Mr., you are dealing with molecules. Okay, you are dealing with molecules. Then for your relative formula mass, you are dealing with compounds. You are dealing with with compounds. So that is the big difference between the two, relative molecular mass and relative formula mass. So quickly we can go over, we have sodium hydroxide. Now you need the basic foundation on how to name different chemicals. If you have not done that, we have got interesting videos on how to know and how to name different elements and compounds as well as molecules. So in this case, we have sodium hydroxide. We know to say sodium has a symbol, any capital and small a. Then oxygen, it is capital O. Then hydrogen, it is capital H. So in this case, we have 3 elements, that is sodium, oxygen, and hydrogen. So we should be able to know that hydrogen here, it has got no any other number related to it. So in short, we only have 1 hydrogen atom there. Then oxygen, we don't have also another number related to it. So what does that mean? In this case, it means that we only have 1 atom of oxygen, even on sodium there, which has no number associated with it. So here we say we only have 1 sodium atom. So in this case, to start our calculations, we are going to say we have 1 multiplied by the mass number for hydrogen, which is simply 1. So here we have a total of 1. Then we have 1 atom of oxygen, which we can multiply by the mass number for oxygen. Now, the mass number for oxygen, it is 16. Now, don't panic. To remember this, you can always check on the periodic table, because in the exam, you're going to go with the periodic table. So don't panic. Then 1 multiplied by 16, you get a 16. Then sodium there, how many sodiums do you have? You only have 1. Multiplying by, what is the mass number for sodium. So sodium has 23 as the mass number. So 1 multiplied by 23, you get a 23. Now, remember that the unit here, it is gram per mole. Gram per mole. And then you have gram per mole. So when you add these, you find that you have 1 plus 16 plus 23. So this gives you a total of 40 grams per mole. Okay, that is your final answer there. Now, what if we were calculating for calcium chloride? Now, here you are supposed to name the number of elements that you have. So you have 1, you remember that calcium has a symbol of Ca, then chlorine has a symbol of Cl, capital C, small l. So this means that we have got 1 calcium there and a chlorine. Now on the chlorine here, we have a 2 down. So this means that we have got these chlorines in this compound. There are the 2 of them. So now we are going to say that and that. So how many chlorine atoms do we have? We have 2 of them. What is the mass number for chlorine? So chlorine has a special mass number, which is 35.5. Now, if you don't know the reason why it's like that, because it's the only element on the periodic table which has got a decimal number. If you don't know the reason why it's like that, the reason is very simple. We say because it's an isotope of chlorine 35 and chlorine 37. So we find the average for those two atoms to get the 35.5. Then chlorine. Okay, we have calculated for chlorine here. Now we go to calcium. We have 1 calcium multiplied by its mass. It has a mass of 40. So here we should get a 70 gram per mole. Then here we should be able to get a 40 gram per mole. When we add, we are going to get that is a 110 gram per mole. Right. Hopefully we are correct. 70 plus 40, 110. Okay. Is it? All right. So quickly, let's also find for the last one, which you guys are going to attempt, and then after you attempt, you see what we are going to get together, if it is going to match with what you are going to get. Okay, so let's have a let's get what we have. Let's get N. Okay, we have ammonium sulfate. We have ammonium sulfate there. Then B, we have aluminium sulfate, like that. So quickly, we have oxygen there, we have sulfur there, we have hydrogen there, then we have nitrogen there. Now, how many oxygens do we have? So we have 4 oxygens there. So we say 4 multiplied by 16, which is the mass number for oxygen. Then how many sulfur do we have? Sulfur atoms here, they are just 1. multiplied by the mass for sulfur, which is 32. Then you go to hydrogen. So you know that hydrogen inside the brackets here, there are just 4 of them, but outside the bracket there's a 2. This 2 multiplies with everything that is inside. So nitrogen here, it is a 1. You have got an invisible 1 there. So you are going to distribute these 2, multiply this by that, then this same 2 multiply it by the 1 which is there. So you are going to say 2 multiplied by 4, that is 8. You write your 8 there, multiply by the mass for hydrogen, which is just 1. Then these 2 multiplied by the 1 there for nitrogen, it will give you a 2. Then these 2 multiplied by the mass number for nitrogen, which is simply a 14. You say this, you can now add them. So 4 multiplied by 16, you get a 64 gram per mole. Then 32 by 1, you get a 32 gram per mole. 8 by 1, you get 8 gram per mole. 2 by 14, you get 28 gram per mole. Okay, so you can now add what you have. Okay, so what do we get? We got 64, 32 plus 8 plus 28. Okay, so you get a total of 132 gram per mole. Right, so quickly, let's go to the next one. Pause the video and try out. Okay, so here we can say oxygen, sulfur, and aluminium. Those are the 3 elements that we have. So we have the same way we said that this 2 is going to multiply with everything inside there. This 3 is also going to multiply. So it's going to multiply by the 4, and also sulfur there, which is just 1. Okay, so we shall say 4 multiplied by 3, it's just 12. 12 by the mass number for oxygen, which is 16. Then we say 3 by 1, it is 3. Then multiply by the mass number of sulfur, which is in this case 32. Then how many atoms of this element do you have? You have 2 of them by its mass, which is 27. So you are going to get 12 multiplied by 16 is simply 192. 192 gram per mole. Then 3 by 32. 32 by 3. You guys should be able to calculate. In case I make an error, you should be able to correct me. So you have 96 gram per mole. Then 27 by 2, this is 54 gram per mole. Okay, so you can add those now. You have 192 plus 96 plus 54, which gives you a total mass of 342 grams per mole. All right, so thank you so much for watching this video till the end. If you need any help, assistance in chemistry, you can contact this number 0972-6386-0767549629. Okay, so this is tutor lawyer for science and math. All right, thank you so much for watching the video till the end.